This time I mean it. Why don't we go ahead and get started. I want to thank you all for coming. My name is Ken Walsh. I'm the Dean of San Diego State University here in Georgia, and we are very, very grateful to you for taking time to come out today. San Diego State, as you may well know, is located in San Diego, California, and we have a number of quaint California traditions that we feel should be a part of our regular activities here in Georgia. One of our favorites at the beginning of an event like this is a little thing we call the silencing of the cell phones. And so if you would take a moment right now, please, to silence your cell phone, we'd appreciate it. We are very excited to have this second opportunity to get a chance to share some of the scientists and engineers who represent San Diego State University to speak a little bit about some of their interests. And so I know that that's the highlight of the afternoon and what you're all waiting for. Before we do that, however, we have a few formalities that we need to complete. I want to thank all of you for coming. I particularly would like to address thanks to the Ministry of Education and Science and the Minister in particular for taking this opportunity to be with us today. I'd like to recognize the support from the Millennium Challenge Corporation and MCA Georgia for our event today. We have a number of representatives of our partner institutions here at this event today, and we welcome all of you. There are a number of my colleagues from San Diego State, and so I'm grateful to them for supporting this event. But the real stars of our event today are those of you who are future students at San Diego State University in Georgia, and you're the ones we're the most grateful for having here today, and we hope this will give you a little preview of what classes will be like and what life will be like for you starting in the fall. It's very exciting to be here and to have this opportunity to offer American degrees that students can study and take right here in Tbilisi, and to follow these opportunities to get education, an American-style education in these critical STEM fields that drive the modern economy. So starting here this September, we'll have cohorts of students studying in electrical engineering and computer engineering and chemistry and biochemistry. We'll have a number, well over 150 scholarship opportunities for helping to support students. We're very excited to have programs that we'll be offering at Tbilisi State University, at Technical University, and at Ilia State University. And we are trying to advance these. This, as I said, is our second in a series of public lectures on various topics from faculty and administrators at San Diego State University. We hope that this will be an opportunity to increase awareness of the importance of STEM fields, of course, increase awareness about the San Diego State University programs, but also to create a public dialogue on a number of very important topics. My colleague, Dr. Stanley Malloy, who's the Dean of the College of Sciences, made our last presentation speaking about climate change and its effect on infectious diseases. Today, we'll be pleased to welcome my colleague, Dr. Alan Swidler, who will be talking about climate change again, but this time from an energy perspective. So before we get to that, I would like to ask for the Minister of Education to make a few brief remarks and to welcome you as well. Thank you.
Thank you very much. Დიდი მადლობა მოგესალმებით ყველას. ბატონმა კენმა ახსენა რამდენიმე ასე ვთქვათ ტექნიკური ფორმალური პროცედურა და ნუ ჩამომართლეთ ფორმალობაში, უბრალოდ მართლა მინდოდა რომ მოგესალმებოდით ყველას და კიდევ ერთხელ მადლობა გადამეხადა ამერიკის მთავრობისთვის პირველ რიგში, რა თქმა უნდა მილენიუმის კორპორაციისთვის, ჩვენი მთავრობისთვის და ყველა იმ ადამიანისთვის, ვინც იყო ამ პროგრამის განხორციელებაში ჩართული, იმიტომ რომ რეალურად ასეთი პრეცედენტი საქართველოში არ ყოფილა და ასეთი მნიშვნელოვანი პროგრამა საუნივერსიტეტო დონეზე, როდესაც ხორციელდება და ამაში ხელშემწყობი არის სახელმწიფო, არის მე ვფიქრობ ძალიან მნიშვნელოვანი. და ძალიან დიდი იმედი მაქვს, რომ ჩვენი სტუდენტები, მომავალი სტუდენტები ამ ყველაფერს აღიქვამენ სწორედ და დაინახავენ თუ რამხელა სარგებლის მიღება შეუძლიათ ასეთი პროგრამისგან. მისასალმებელია, რა თქმა უნდა, ის ფაქტიც, რომ გარდა იმ კომპაქტით გათვალისწინებული პროგრამებისა, მრავალი ინიციატივით გამოდის სან დიეგოს სახელმწიფო უნივერსიტეტი, თუნდაც ის მომენტი, რომ დღეს ჩვენ ვართ აქ და ვისმენთ საჯარო ლექციებს, ეს არ არის ჩვეულებრივი პროგრამის ნაწილი, მაგრამ არის ინიციატივა, რომელიც არის ძალიან მნიშვნელოვანი, ძალიან კარგი და საშუალებას მოგცემს, რომ ვისაუბროთ და განვიხილოთ ის თემები, რომელიც ძალიან აქტუალურია საქართველოში და კარგი იქნება ამ თემებს თუ დავინახავთ ასე ვთქვათ სხვისი თვალითაც და გარედანაც. ამიტომ ვფიქრობ ძალიან საინტერესო სემინარი და საჯარო ლექციები გველის დიდი მადლობა კიდევ ყველას და მე დიდი სიამოვნებით დავესწრები და მოვისმენ.
Thank you very much. As you know, the SDSU Georgia program is a jointly funded activity sponsored by the Millennium Challenge Corporation through MCA Georgia and the government of Georgia. And we are very, very grateful to you for your support of this program and for being with us today. So thank you. So it's now my great pleasure to introduce my friend and colleague, Dr. Allan Sweedler. Allan is an Associate Vice President at San Diego State University in charge of our international programs. He's also a professor of physics at San Diego State University. He's been very accomplished in a number of arenas, particularly in his own research areas in superconductivity, and moved on over the course of his career to a number of important posts and research focused on energy policy. And so what I'm really pleased about today is that we'll have the opportunity to hear his experiences of that work and his impressions in terms of where that leads for the impacts of climate change and energy security. He'll talk a little bit about the specific impacts here in Georgia and some examples from our own region in San Diego. So I'm sure you will enjoy it. And with that, I would invite Dr. Sweedler.
Well, thank you very much. It's indeed not only a great pleasure, but a great honor to be here to speak to you this afternoon. I'm very humbled by the quality and the size of the audience. And I hope that the topics that I discuss will be of interest to you, and I welcome very much your feedback and questions, and I hope we have a lively discussion. What I'm going to try to do, and I don't know if I'll be successful, but I will try, I'm going to weave a story. I'm going to try to bring together a variety of things that many people talk about separately. And I'm going to present to you, to begin with, a global perspective on these topics. And I hope if there's time, we'll be able to talk about some examples from where I come from, San Diego, California, and Georgia, where I'm visiting now. So the things I would like to bring together are the use of energy, and I'm also going to talk about a little bit about water, which is very closely related to energy, how climate change is a result of the use of energy and the impact that has, and also what many people don't necessarily connect is actually security. Security of a country, security of a region, and security of the whole international community. So let's begin. I think it should be fairly evident that there is a connection, but just in case we want to make it a little more formal, I put down some things here. That obviously reliable and secure sources of energy are vital to the functioning of any economy, to the functioning of any society. And therefore it's vital to the security. Without secure energy supplies, I don't have to tell you, it's hard to imagine a functioning society. But climate change and associated global warming has a tremendous impact on security. And in fact, in the United States, the Department of Defense has made the following rather dramatic statement, if you think about it. Projected climate change poses a serious threat to America's national security. Climate change, national security, and energy dependence are a related set of global challenges. So keep that in mind. That's the official policy of the US government. Now, because the use of carbon-based energy, I call that, instead of fossil fuel, it's a little more accurate, is so closely related to climate change, clearly they are also related to security. And I'll try to develop that. And my main thesis is that these entities, these elements, will become more and more important in the 21st century. And unless we understand them, we are likely to have difficulty responding to the consequences. So, what drives global energy demand? What makes so much energy needed? Well, obviously, population growth and economic development are the two key things. Now, much of this is self-evident, but when you start to put it together, I'll show you some data and graphs which will make the point. Right now, over 80% of all the energy that's used in the world comes from three main sources: petroleum, coal, and natural gas. And despite the desire of many people to change that situation, the energy sector is enormous. It's the largest sector in the economy, globally speaking. And so it's very difficult to change that. And so for the next 30 to 50 years, the projections that I've been involved in myself and that I've seen, it's likely it's not going to change that much. So as much as one might like to have a change, the inertia of the economy and the realities of economic development argue against that. But that doesn't mean we can't begin the process. What some people don't quite realize is the growth for energy is going to be greatest in Asia and Africa. And I will show you some points about that. And there's another element. We've coined the term watergy. I don't know how many people have heard the term before, but this is becoming more and more important. And there are articles and books and conferences and courses that we give on the connection, the synergy between water and energy. You need energy to process water, to move water, to purify it, but you also need water to generate energy, to cool power plants, to cool solar plants. So there's related factors there. In fact, 20% of the energy in California goes for water-related purposes. That's a very large 1/5. Globally, it's about 17%. So a lot of the energy is associated with water. And I'll show you some striking figures later on as we go through the talk here. But who uses energy? It's people. And you cannot talk about energy, water security, climate change without discussing the population and the rate of growth of population. This is a remarkable figure anyway. And you see this goes back almost into the infinite past. This is a church in Nigeria. So it's a rather remarkable phenomenon, something we're not used to seeing. But it's a metaphor, and it's a pictorial representation of some of the data that I'll show you. So let's look a little first at population. I think many of you are aware of it, but I suspect that some people may not be aware of the actual numbers and the history. This is the population growth of the human race over time. Look at this graph now. For most of human history, there were probably 300 million people or 400 million people on Earth. In the past 100 years or so, this has climbed to where we are now, about 7 billion. So, over a very short historical period of time, the human population has exponentially exploded. And we don't know that necessarily, although many of us do feel it, because in our own lifetime we may not experience it, although in recent times people have. But the impact it has on society, on economic growth, on the environment is tremendous, and it's profound. And to bring this back to our own era, look at this graph here. This shows that before 1800, there were fewer than 1 billion people, but between 1800 and where we are now, so that's 100, 200 years, 7 billion people have populated the Earth. and it's still growing. This projection shows about 9 billion at the turn of the century. The latest figures in an article published recently in Science magazine shows that the rate is even faster than that. So in a period of time from 1960, 14 years, 1 billion people were added to the earth. And you have a similar, that's almost the population, or more than the population of China. One China added in 10 years. And the growth continues. I think most people would argue this is unsustainable, certainly in human lifetime terms. But what most people don't realize is how the population is distributed around the globe. This is a series of pie charts that I put together from various sources, which show that historically, 1950, you have more than half the population in Asia, but you have a fairly big chunk in Europe, North America, and Africa. We are now here, roughly, 2010. A larger chunk is in Asia. Now, here, Africa is increasing its proportion. Europe is about 10% still, and here we are in poor North America with not many people. But you'll be joining us soon. Now, keep in mind, this is proportional percentages, but the pie is much bigger. So it's 60% of a much larger pie. Now we come to the projections, and this is what's astounding. By 2050, 78.9% of all the people on Earth will live in Africa and Asia. We in Europe and North America will be a tiny portion because of economic growth, because of population growth, particularly in Africa. And when you have a small growth on top of a large population to start with, even small growth rates result in a large number of people. So now Africa is about 23%. Asia is more than half. And here's little Europe, and here's little North and South America here. By the turn of the century, which many of you students will be alive, certainly in 2050, many of us will still be alive, we hope. It'll be crowded, but we'll be alive. We have a situation which, to my mind, is mind-boggling. Almost 81% of all human beings will be in two areas, Africa and Asia. 45% in Asia, 35% in Africa. Europe, it's getting smaller all the time. I looked at the population growth for Georgia, just to put it in context, it's pretty flat. It's not going to change very much, as you all know. And North America will be even smaller as a percentage. So the traditional view, the education we give our children, the geography classes we take, will all have to be revised. Because there won't be many people living in the areas that we talk about relative to the total global population. Now, I don't have to tell you the implications of that, but I'll discuss some of them. Now, here's another graph that you might find interesting. These are some selected countries, and we start back here in 2010. Now, when we get we're over here about now, and we can see a country like Nigeria. Nigeria is exploding, both politically and population-wise. It's going to have close to 750 million people by the turn of the century. Even by mid-century, it's going to have 450 million people. The United States is in fact one of the only, if not only, so-called developed, industrialized countries that's still growing. It has the third largest population in the world. People don't realize that. After China and India, United States. But the consumption pattern per person is very high. So the environmental impact is great. And by the turn of the century, the US will have almost 500 million people. But other countries, Russia, we know, is declining in population. Europe, Germany is declining. Some of the countries in Afghanistan, Brazil is increasing but will go down. But look over here, China and India. China now has about 1.3 billion people. It's going to decline, but decline to what? Same thing, pretty much. And then it's going to decline, but still it has 950 million people. But India India is projected to grow to 1.7 billion people. And then it declines to 1.55 billion people. So, if you were a planner in those countries, or if you were a student, or if you were thinking of what to do with your life, everything that one does, everything, energy, water, planning, crime, security, economic development, social interactions, quality of life, everything is going to be influenced, impacted, affected by these enormous population numbers. Now we can talk later. Now this is a very delicate subject because I'm taking a risk talking about this publicly because it evokes a great deal of questions about morality, ethics, religion, and what it implies. I'm willing to engage in that discussion if we have time, but I should tell you that in my view, not enough people are thoughtfully thinking about this. And as we not think about it, the background keeps growing more and more. But we cannot avoid it any longer, in my view. The numbers are just too dramatic. Now, it isn't just population that drives energy demand, it's also economic growth. And this is an interesting graph. As countries develop, like China, India, Brazil, they use more energy per person, not just more energy absolutely, per capita. And so this is the GDP per capita, and this is the energy use per capita. So you see South Korea, its population is relatively stable, but it uses more energy per person. The United States has been pretty flat for a while. Some countries go backwards in the decline after the collapse of the Soviet Union. You know the economy collapsed. I don't have to tell you that. Therefore, energy use went down. But a collapsing economy is hardly a desirable method of reducing energy demand. I don't think anyone would argue that in any serious way. So I point this out to show that increased development usually increases energy demand, but not all the time. Look at the example of the United States. Because we have very, very strict policies and regulations, generally under the rubric of energy efficiency, which is a big discussion here in Georgia, you don't have to increase energy demand by increasing as population increases or as wealth increases. So this is a normalized graph, and you can see energy use per person in the US has gone down, and is projected to go down, because we have more efficient cars, we have more efficient refrigerators, we have more efficient lights, etc. And also the economic output of energy, you don't have to increase energy to increase economic development. You can decrease energy, this is per dollar GDP, if you use energy efficiency. Now, since I'm a professor and I teach classes, I would point out to you the difference between conservation and efficiency. Conservation is you use less energy. Efficiency, you use less energy for a certain task. So if I have a car that gets 25 miles to the gallon, a refrigerator that uses less electricity, but I drive twice the distance because I have an efficient car, I don't save any energy. Or if I have a refrigerator and I put it down in the basement and use it as a second refrigerator, I don't save any energy. So efficiency by itself will not help. It has to be efficiency plus conservation. Now, here's the connection to climate change. This is a dramatic graph, I think. This shows, without the shadow of a doubt, that the more people you have, the more carbon dioxide you put into the atmosphere. One-to-one relation. It's almost a linear curve. And this means that unless the whole cycle of energy changes, this will continue. We are now somewhere, as we know, actually it's up around here, about 400 parts per million. But as recently as, well, I don't know when this actually starts, but not too long ago it was down to 350. Historically, it was at numbers like 200. So keep in mind the amount of carbon dioxide that's being put into the atmosphere is much greater than any time before. But the real point is it's the rate that it goes into the atmosphere. There's always been carbon dioxide in the atmosphere, which has fluctuated, but this is over cycles of hundreds of thousands of years. Only recently have we dramatically increased the amount of carbon dioxide in a very, very, very short time. And the atmosphere isn't used to absorbing that amount of carbon dioxide, hence it warms up from the greenhouse effect, which I'm assuming many of you know, which if you come to SDSU Georgia as a STEM student, you can get a whole lecture on what the greenhouse effect is. Okay, so a quick summary. Population could be 11 billion by 2050. 80% of the people live in Asia and Africa. Now these may be stark numbers, but I'm basically an optimistic person, so I'll give you some, hopefully some ways out of this. The remaining 20% will be in North and South America and Europe. North and South America and Europe, including Russia. India will have the largest population, 1.5 billion. Now, if you've been to India, I gave a similar talk in India, and I certainly couldn't tell them not to use coal. That would have been very hypocritical of me, because my country got rich using coal in the 19th century, so I can't say you shouldn't get rich using coal. But I pointed out to them, who is going to be the losers if India takes the same development path that England or the US took using coal? It's Indian people. They're going to have the bad air to breathe. They're going to have the pollution. So it isn't what the United States or Europe has done in the past, it's what countries choose to do right now that's important for their own people. And so this argument about, well, it's unfair, you've cut down trees, you've used it, it's not incorrect, it's irrelevant. It doesn't address the present or the future. There's really no right or wrong here, there's just a series of stark facts. Well, let's now go back to energy. If we want to see what's happening in energy in the future, we have to know where we've been. This is also a very interesting graph. It was put together by John Holdren, who's now the science advisor to President Obama, and I've known him for some time. Energy has, you can see, dramatically increased in terms of its use just in 150 years. But it's shifted. Biomass is a fancy way of saying trees. People cut down trees and burn them. And then it's gone to coal, oil, and now more natural gas. So this is where we have been. Now, but where are we going? These are projections from the International Energy Agency. And I was recently talking to the minister last night. The International Energy Agency, along with the EU, has come out with a new paper just 2 days ago about energy in the South Caucasus, which, if you can get a copy of it, first send me a copy because I haven't been able to get one, but then read it yourself. So they have a very sophisticated analysis of where energy is going here. But this is globally, and this is what I meant earlier. First of all, the absolute amount of energy is going it's going to double in 2040, which is 25 years from now or something like that. And the proportions are not going to change all that much. There's still going to be a base of oil, coal, natural gas. Renewables will grow, but it's still, unfortunately, a very small amount, and nuclear power will make a contribution as well. So my point here is that the immediate future is going to be very similar to the present and the immediate past. And we have to think of ways to compensate or deal with that, because it's unlikely that the energy sector is going to do a dramatic change in such a short period of time. And there's been energy transitions in the past. This is the percentage of energy used year and the type. So this is trees. We no longer cut trees down so much. This is coal. The use of coal has peaked in a certain way relative to its percentage because oil and modern fuels have come in. So we've made this transition from wood to coal to oil, natural gas, question mark, what's the next one? Now, I'm not going to dwell on this. This is for the students in the class who take the course in energy that I teach. This is called an energy flow diagram for the world. It's a useful analytical tool. It tells you what goes in, what it's used for, what's wasted, etc. This is used in modeling and analysis. Okay, now you can ask the question, why are oil, coal, and gas so pervasive? The reason is, from a physics or chemical view, the energy in the carbon-hydrogen bonds is very, very strong. It's the second most powerful after nuclear bond. So when you break those bonds, you release energy. It's powerful and it's compact. And that's why I show this 747 here. Just think about it. I've sat in too many airports, but I've sat in airports looking out the window, seeing this enormous machine, this airplane, it's huge. It just goes down and it goes slowly up in the air, very slowly. It goes up to 10,000 meters, goes 550 miles an hour, halfway around the world, comes down like a feather. All of that happens because of the energy in the carbon-hydrogen bond in the oil and jet fuel. So it's an incredibly useful thing, petroleum. You can't run a plane on coal. You can't run it on natural gas. You can't run it really on nuclear. So the use of oil is going to be with us for a long time. We have to figure out how to burn it cleanly and capture the carbon. So the reason there's so much oil that's used, and therefore I'll show you how it works with security, is because it's really a good fuel. It does what we want. It drives our cars, it flies our airplanes, and also much of it is used for fertilizer in agriculture. So it's not that this is an all-pervasive evil. It has done some very useful thing. The question is now, its use may be becoming, its costs might be greater than its benefits. Okay, so not only oil, but the new energy, global energy, is natural gas. Natural gas, as you know, I don't have to tell you that, you get natural gas from Soviet Union, from other places in pipes. But that's going to change soon. Soon countries are going to liquefy natural gas, and it's going to be transported around the world just like oil is. And here are some of the potential routes. It's going to come from Australia, and it's going to go to Asia, to Europe. The United States is going to export natural gas soon. And these are these huge tankers that are floating bombs, actually. They liquefy the natural gas, and then you re-gasify it. So we're going to see more of this. Remember this talk in a few years from now. Now, the same thing has been true for oil. So a lot of oil comes from the Middle East, goes to Japan, to North America, to Europe, etc. Well, at any one time, there are probably 20 supertankers on the sea, carrying enough oil for a 2 or 3 week supply for a country the size of the United States. Any one of those tankers gets hijacked, gets sunk, gets attacked, there goes a lot of oil. So there's vulnerability. And what I'm arguing is that there's going to be vulnerability for natural gas as well when they start. So that's where the security starts to come in. Countries are dependent on this complex system without most people even really knowing about it. And the price of oil, I don't have to tell you anything about that, it's highly vulnerable. So a society that depends on oil, now Georgia is sort of an interesting case because you have a lot of hydropower, but you depend, like every other country, on oil for cars and trucks and airplanes, trains, anything that moves needs petroleum. But the price is all over the place. How can you plan? How can you plan an economy when your major input is doing this? Well, right now it happens to be going down, but it's not going to go down for long, believe me. It's going to start coming up, and now we're here. I guarantee you, if I give this talk again in a year or two, it's going to be back up here somewhere, for sure. So don't get lulled into false sense of security. What about renewable energy? Everybody talks about renewable energy, which is a good thing. This is projections from the World Energy Outlook, and you can see that the percentage of hydropower is increasing, and the same thing for wind and solar. But don't forget, relative to what it was before, the rate of change is high, but it's from a very small base. So the absolute amount is relatively small, but increasing, which is good. Where is this energy demand going to come from? As I said, the OECD, you all know what the OECD is, the Organization for the Economic Cooperation and Development, the so-called developed countries, Europe, Western Europe, Japan, Australia, North America. The demand there is going to be relatively flat. Why? Because the population isn't growing too much. The energy per person is going down. They're getting more efficient. China is still on the development path, but here's where this rest of the world, India, Africa. Africa is exploding in terms of energy use as it develops very, very strongly. So here's a little summary from something called the World Energy Outlook, which many of you may be aware of. This is a group from the International Energy Agency. It's an international group based in Paris. And here's what they say in its last report. The current calm in the energy markets shouldn't disguise the difficult road ahead. I've indicated some of the reason why. Turmoil in the Middle East. I think many of you know there's a critical meeting in Paris in December. Perhaps maybe someone here representing Georgia. Certainly at that about climate change. So what happens there? Are there going to be limits? We don't know yet. There's an enormous amount of subsidies, $550 billion. And what's going to happen in terms of global energy? You know, there are global treaties for water, for air pollution. There's no single international treaty for energy. Every country acts as an independent actor, as my political scientist friends say. They all try to maximize their own benefit, but every country can't maximize its own benefit without other countries having to pay a price. And that's the situation we're in. I don't think we need to see it. Now let's talk about water. Water is critical, as I mentioned, and I just want to show you this close connection. It's a little cartoon. By the way, I'm going to leave these slides here for the students who want to look at them later. So you need water to cool power plants, but you need energy to move the water, and I think you all are aware of that. But this is an interesting chart. Let me spend a little time on this. It's fresh water that we need for agriculture and for human consumption. But of the amount of water in the world, only 2.5% is fresh water. Fresh water, lakes, rivers, streams. And of that fresh water, only this tiny fraction you can use for human consumption. A lot of it is in permafrost. And of that, it's rivers, waters, etc. So you really only have this tiny fraction of water that's available. And I saw an article in your paper yesterday in the Georgian Times that the World Bank is predicting a 55% increase in water demand by 2050. Almost this increase of 55%. It's going to be huge. And that's because of the population growth. So, but there isn't that much water around. You know, if you look, I live in San Diego. I have a hard time convincing people there isn't much water because they look at me, you're crazy. Look, there's the Pacific Ocean. But the energy required to get the salt out of the water is enormous. So if you have a lot of energy, you can get water. But if you're energy constrained, you're going to be water constrained. And we know that now in our part of the world. We are in a severe drought. We have restrictions. And there's a great quote that some of you maybe or may not appreciate. There was a lot of articles on water. And to show you how much education needs to be done, there was a quote of a citizen in San Diego, because you can't have a lawn anymore. You can't have a green lawn. So she said, I'm really mad at the scientists. They told us that the polar bears are going to be affected by climate change, but they didn't tell me I couldn't have my lawn. So you can see how far a road we have to go. This is another interesting. This is the amount it takes. 10 liters of water to make paper. Look at this. 15,500 liters to get 1 kilo of beef. 10,000 liters to make jeans of water. manufacturing. 1,300 liters for a kilo of wheat. So but see, pigs aren't as water hungry as cows. But most people don't know the numbers. I like beef, many people do, but if it takes 15,500 liters, I'm going to change. Okay. So here's the main points about water, G. Water is needed to produce energy and vice versa. The water and energy sectors, they're closely linked, but people in water don't talk to people in energy, and vice versa. California, as I said, 20% of the electricity comes from uses for need of water. And desalination looks like, what's the problem? But it's very, very energy intensive. Now, I should say, obviously there's a lot of areas for research here. New technologies, new companies, new ideas. And most of those will require STEM education. Scientists, engineers, mathematicians. So if you're interested in the environment, if you're interested in doing something, a STEM education is the best way to go about it. Okay, now we get to climate change, and then we'll bring it all together. Some people think climate change isn't happening. I think they have their heads in the sand. If you ask yourself, what do you expect to see as a scientist? If there's really climate change taking place, that's a hypothesis. You should ask for a result. That's what scientists do. You have a hypothesis, test it. What results do you expect? Well, if there's climate change, this is what you'd expect. Humidity to increase, temperature of the oceans to go up, sea surface temperatures to increase, the heat content of the ocean, etc. So this is what you expect. Now let's look at the data. The data, one-to-one, corresponds to what you expect for climate change and global warming. Global warming is one element of climate change. Ocean acidification is another. Sea level rising is another. Global warming is just one small part. So this is the temperature over the land. This is the sea surface temperature. This is the sea level. This is the melting of the ice caps, and etc., etc. Lots of data sets. This is from what's called the IPCC Working Group number 4, the latest one. And so this is the latest set of data going up to mid-2000 here. And it's Working Group 5, the annual report. It's called Assessment Report. This is what's going to be discussed in Paris and the other areas. So if you take an objective look at the data, at all of the data, not what's called cherry picking, not just picking little pieces, the argument is compelling. The data is compelling. Okay, now let's get to security. Let's bring it all together now. One thing that's important is to note the difference between national security, the security of my country, and international security, the security of a region or even the whole globe. And there's a big difference. National security refers to individual countries, nation states, and it usually means the physical and political stability of the country. That's pretty clear. You have militaries for that, etc. International security refers to groups of states, groupings together that have collective type of security, regions or the whole global community. Now, here's the thing that most people don't realize. What may increase national security may decrease international security. So what you think you're doing for your country to be stronger may make someone else feel weaker. And if they feel weaker, they're going to do something to feel stronger. And then you're going to do something to feel stronger. And before you know it, you have an arms race. And that's, of course, what happened for most of the period of time, from 1945 to relatively recently. But it goes all the way back in history. It goes back to the Athenians in the Peloponnesian War. And in fact, if you read the Peloponnesian War by Thucydides, you could be reading modern history. The same problems over and over and over, usually related to resources. Now it's going to be related to energy, water, etc. And energy is a good example where the policies can conflict. Now let me give you a case here. Let's take a case of 3 big countries, the United States, Russia, and China. Well, our president says we have to be energy independent. That's impossible. No country can be energy independent. What he really means, we have to import less oil. And many people in the US say we shouldn't import any oil. We have our own oil, we shouldn't import it. Well, it sounds pretty good, nice little soundbite, good if you're running for office, but think about the implications of that. First of all, you're taking something that's very useful and you're using it and that's the end of it. You should be saving it for maybe the future, possibly. But if the US became energy independent and didn't import oil, and say Europe and China do the same, well, what happens to countries like Russia or Mexico, or Saudi Arabia, Nigeria, Iraq, Iran? Their economies will collapse. And is it really an advantage if a country like Russia gets poor and chaotic and has no economy when they have 10,000 nuclear weapons in their backyard? What kind of security is that? That's hardly security. That's what I would call insecurity. But the policies that we pursue appear to maximize our own benefit, but in fact, when you take this perspective, undermine the very goals you'd like to obtain. Mexico. Mexico is a complicated country. It has many positive and stable things. It has a lot of instability. But oil is a major source of income for Mexico. If the US stopped importing oil, we would have chaos on our own border. And if Russia couldn't sell its oil, you would have big problems. And so let's look about climate change. So it doesn't do anyone any benefit to make another country really weaker, particularly when they have a lot of weapons. Now what about climate change? Some people argue climate change is great. Russia has said, oh, we're going to open up that Northwest Passage now, send ships of petroleum over to Norway, come down, great, it's going to increase the economy. Canada is opening up parts of the Arctic for exploration. So to them, they see global warming as a benefit. So there's no reason for them to cut down on the use of fossil fuels. But for others, island states, most of humanity, it's a negative because of droughts, because of extreme weather, because of unpredictability, etc. But if a group of countries refuse to negotiate about climate change, and another countries feel their very security is threatened, that's a classic prescription for conflict. So climate change policies are really about conflict and conflict management and resolution. They only appear to be about the atmosphere. That's the facade. What's going on behind the picture are these much more serious things. And so people who study this recognize that, and it's not usually made explicit, which is what I'm trying to do now. Okay, so what will it take to change the path that we're on? Well, it's pretty obvious, really. We have to recognize that the current course is unsustainable. I don't have to tell you that, that's self-evident. But not only is it unsustainable, it's very dangerous. Because it will, I would be emphatic about this, it will lead to conflict. Countries will not give up their supplies of water or their supplies of energy. They won't tolerate other countries doing things that undermines their climate and their agriculture. But if you really want to get deep understanding, you have to understand that climate change, water security, they're global issues. It doesn't matter what the US does, it doesn't matter what Georgia does. We're really in this thing together. And right now, we have treaties about air pollution, we have treaties about ocean going. There are no treaties about energy. No treaties about, it's just an act of accident that Saudi Arabia sits on all this oil. Or Iraq does, or Kuwait. And the best little joke, or not so joke, about oil and conflict is when the US went to war in Iraq, and particularly when the first war over Kuwait, the comment was, well, if Iraq grew cucumbers, the United States would not send soldiers there. But Iraq had a lot of oil, and oil was perceived as security. So we need to have international norms that regulate greenhouse gases, etc. So the elements, they're difficult, but they're not impossible in my view. We have to reduce the amount of energy used. That means conservation brought about by efficiency. And that means new companies, new technologies, new ideas, new ways of looking at things. So we mentioned superconductivity, which I've worked with, and my colleague Alexander here has as well. And there's some interesting work going right here in Georgia about that. Energy efficiency, which will use the limited resources. This requires research, development, trained people. The energy field is not for the faint-hearted and not for the unskilled. Energy professionals need expert training in physics, chemistry, mathematics, engineering, computer science, all the things that are associated with the STEM fields. We have to begin to think about shifting away from carbon-based fuels, even though it's going to take, if we don't start thinking about it, we'll never get there. If we don't have a road that we're starting to take, we'll never get to the end of any road. We'll just sort of chaotically bounce around without any direction. This will, of course, result in reduction of global greenhouse gases, and we have to increase the non-carbon energy. We know what they are: wind, hydro, geothermal, solar, biofuels. We know what to do. If we let this happen, it's our fault. We know how to control population. We know how to produce clean energy. If we don't do it, we have no one to blame but ourselves. And we need, here's where the international relations people come in, the social scientists. We need to have regulation of the energy and climate issues. Okay, now I have a few more minutes, I think, do I? Okay, 3, okay. I do want to talk about some specific cases that relate to you in Georgia. So I've chosen 2 regions, San Diego and Georgia. Here's where I live, and it's a full region. It's not just one country. It involves another country, Mexico. Here's where you live. And I've listed a few similarities and a few things that are different. The economy is quite bigger in San Diego. We also have no energy resources. We have no oil, we have no gas. We don't have any hydro, at least you have hydro. We have no, all we have is sun and some wind. And in Georgia, you have very little oil and gas. Your main resource is hydro, but you're in the strategic location about transshipping. But we're in the worst. We're in a non-strategic location. We're at the end of the pipeline for everything. Water. In fact, people have said, you take the United States and you tilt it on its side, you know, this is east, this way, and then you tilt it north-south. All the nuts flow right to the end, which is San Diego. So here's the analogy thing with Georgia. We have cross-border connections in electricity and gas, the way that you do. And this is a study we did at San Diego State University. We actually did a really sophisticated analysis of what kind of energy could be used in our region, and we found enormous amounts of probable energy. And similar studies are taking place. In Georgia, you have transit lines for gas and oil. You have, actually, you may not know it, but Georgia has a considerable amount of renewable energy potential, very large amounts, but only 3% right now of electricity is generated. These renewable energy resources in Georgia are solar, wind, hydro, geothermal, biomass. Some reports I've seen suggest that Georgia could supply 1/3 of its energy from renewable sources. And of course you have large hydro plants. But be aware of hydro plants, they depend on water. Water depends on climate. Climate is going to be affected by climate change. So you may end up building a dam and find there's no water in the river in 20 years from now. So these are some of the connections you have. This puts you can sell power, make money from that. That's a good thing to do. And here's a little map of some renewable resources for Georgia to give you a sense. And in preparing this lecture, I came across 2 very good studies by colleagues of yours, and now there's a 3rd one out. I'll list them here. They're on the web if you want to find them. They're pretty up to date. This is 2014, this is 2013. Maybe you know some of these colleagues of yours. So I'll just end by saying, for those students who are interested in coming participating in San Diego State University, Georgia, we do research and teaching in all of these areas. We have programs in science, sustainability, power engineering, geological sciences, grid stability, renewable energy, climate change, modeling. We have a program of Homeland Security, which is an online program, conflict resolution, and international relations. So all of this stuff comes together in an academic setting. And I'll just end by saying, it's up to us. There's no magic bullet. No one from the sky is going to come down. We're not going to go to another planet and live there. The action is right here. And in fact, you're right in the middle of it yourselves. Thank you very much.
So if we haven't completely exhausted you, we thought we might take a few minutes to see if there were questions that we could deal with. And so if you have questions about energy and energy security and climate change and all of that, those are really hard questions, and I invite you to ask Alan. If you have questions about San Diego State University, Georgia, and the programs that will be offered here, those are really easy questions, and I hope you'll direct those to me. So please.
პირველ რიგში დიდი მადლობა საინტერესო ლექციისათვის. და გვაქვს რამდენიმე კითხვა. რამდენად ცნობილი ფაქტია, გასაუბრეთ მიროფირცევანი ენერგეტიკისა და ელექტროინჟინერიის დოქტორი. თქვენი მოხსენება
I'm sorry, could you repeat the question in translation? Okay, I'm sorry. Yes, can you repeat? No, you're speaking in. Okay.
ელექტროინჟინერიის დოქტორი მიროფირცევანი.
Okay.
მადლობ საინტერესო მოხსენებისათვის. ცნობილი ფაქტია, რომ კლიმატი და დათბობა ეს საერთაშორისო პრობლემა გახდა და კითხვა გვაქვს ასეთი. რამდენად ძლიერია საერთაშორისო ორგანიზაციები და მათ შორის მეცნიერული წრეები, რომ აიძულონ სხვადასხვა ქვეყნების თავრობები და გათვალისწინებული იქნას ის აუცილებელი ღონისძიებები, რომელიც თქვენ ჩამოაყალიბებთ და თქვენს გარეშეც არსებობს. ეს ერთი, მეორე ვთქვა თუ ჯერ პასუხი და მე გავუშვი.
Well, maybe I'll just respond to the first one first, okay? Okay, so you all heard the question in one form or another. Basically is what's there to force governments to do some of the things that I've been suggesting. And of course, there's nothing there at the moment, except the realization that we're sort of in a ship that's going down slowly, and because it's slowly, we may not recognize it. And unless we do something together, it will be very much more difficult to do things later. There is a general feeling, I would say, in the scientific community that this is the year that some sort of limitations on emissions to the atmosphere needs to be put in place. And public opinion is shifting quite a bit in favor of this. There was a recent poll in the United States, which you may know, many people do not agree with this view, suggesting that well over 60% of the people now understand global warming and want the government to do something about it. Now, I should mention to you, doing something about it can also translate to economic development. Because doing something about it means new technologies, means better ways to use energy, new computers that use less energy, new cars. So it's not a question that we're going to have hardship by changing the energy system we use. There may be a period of transition where there's some uncertainties, but it represents really the future. We can't keep burning coal forever. There's only a certain amount of oil in the ground, even though there's a lot. At some point, the human society has to move to a different type of energy system. Why not start now? So my answer to your question, there's an inherent logic which is growing, and governments are now recognized. The historic treaty between the US and China, which just took place, is a manifestation, a recognition that governments now realize they have to do something about this because their own populations are becoming more aware of it, and the longer they wait, the more difficult it's going to be.
დიდი მადლობა. თქვენ ბრძანეთ რომ ენერგიის მიღება უფრო რეკომენდირებულია ეგრეთ წოდებული სუფთა ეკოლოგიური პროცესებიდან გამომდინარე. კერძოდ წყლის ენერგიის გამოყენება. საქართველოში 70% ჰიდრორესურსი გამოიყენება. მაგრამ
We have a translation here. Did you get it? I'm sorry. Did you?
მაგრამ მედალს ორივე მხარე აქვს. დიდი წყალსაცავები იწვევს დიდი მოცულობის დატბორვებს და უარყოფით შედეგებს. ამ შემთხვევაში თქვენი შეხედულება როგორი იქნება ამ პროცესთან დაკავშირებით?
The question is that large hydro is a big source of energy in Georgia, but there are downsides, flooding, enormous costs. And by the way, globally, dams are being removed, actually, because of the ecological damage they do. And the World Bank is getting more and more reluctant to finance very large dams, partly because of climate change. But let me respond a little more specifically. It's true that large hydro is a major factor in electricity use in Georgia. It doesn't help at all with the cars and the trucks. You still need oil for that. So if you're talking about only electricity, you're only looking at a certain part of the energy sector. And there's a truism in energy analysis, for those of you who study it. I try not to use sayings, but it's very appropriate here. Do not put all your eggs in one basket. That means any country that relies on only one source of energy is going to be in big trouble, whether it's hydro, nuclear, coal, or whatever. So the most stable energy situation is what's called a portfolio of different types of energy for different needs. And in the case of Georgia, you have hydro for water, but as I said, that's uncertain because of climate change over the long run. And as you know, when the rivers are low in the fall, you don't have much power. And when they're high in the spring and early summer, you don't need that much power. But you need to find alternatives for petroleum and for natural gas. Or you need to use those much, much more efficiently. And then you need to develop, or should develop, the renewable sources, which generally speaking, are much more stable. You wouldn't think that solar energy is a big thing in Georgia, but I showed you this map. There's quite a bit of solar resource. And wind power is very, very popular now all around the world. But I don't want to mislead you. That's not going to solve your problem. You're going to need oil and gas and hydro for a long time to come. But one should begin to reduce the dependence on those fuels as much as technically and economically as possible.
და ერთი კითხვა შეიძლება. თქვენი გამოცდილება გვინდა თბილისი წარმოადგენს ალბათ ევროპაში ერთ-ერთ ყველაზე დაბინძურებულ ქალაქს, რომელიც ძირითადად ტრანსპორტის გამონაბოლქვისგან არის წარმოქმნილი. როგორია თქვენი პრაქტიკა და საერთაშორისო პრაქტიკა მილიონიანი ქალაქისათვის ეკოლოგიური გამოსვლების მიზნით?
The question was air pollution. Air pollution in Tbilisi, which he says is quite bad, which I could believe. I didn't mention it, but there's a very close connection between global warming and air pollution. The same pollutants that pollute the air, what's called PM, particulate matter, very small amounts, the polycarbonate hydrocarbons, these are all also related to global warming. So the same causes that bring about global warming, the burning of particularly coal, also are the main causes for air pollution. So when one thinks about reducing greenhouse gas on the global level, what you're really doing as well is improving the air quality for the people who live in the cities. And that's been shown over and over again. Los Angeles is a good example. Los Angeles has not very good air, but its population has increased dramatically in the past 50 years, and the air quality has stayed about the same or gone down because of very strict regulations. So the way you do this, you reduce the use of coal, like they did in London. You make automobiles as efficient as possible, and you provide relatively clean burning fuels instead of the traditional petroleum. That's by increasing. And all of those things taken together improve the air quality and also reduce the causes of climate change. You had a question, sir? Yeah?
My name is Archil Magalashvili. I'm a head of Engineering and Geosciences Department at Ilia State University. First of all, thank you very much for your wonderful presentation. My question is dedicated to the things that was not touched during your presentation. You mainly speak about connections of water and energy. And what about the mineral resources? How they are connected and what the influence of these two things?
Yes.
Thank you.
Well, if you mean water to extract the mineral resources, if that's what you're referring to, you're absolutely right. If you've ever been to a mine, any kind of mine, oil, metals, semi-metals, precious metals, enormous amounts of water are used. And just think of the tar fields in Canada. These enormous, thicky, gooey stuff takes incredible amounts of water. In fact, I should get a slide how much water really takes to produce oil. So, if water is a critical, and fracking, I don't have to tell you about fracking, hydraulic fracturing, where you don't just put water down a well to split rocks. That's what people think. You put water plus a lot of chemicals. Now, what are these chemicals? My colleague Stanley Malloy, who was here last week or recently, they're called biocides. They're toxins, and they're there to kill the bacteria that eat the oil. And it's a big secret what they are, but they get into the environment. They leak into the water table. So the use of water and the extraction of fossil fuels, coal, oil, natural gas, carry a whole set of environmental problems, which will only become exacerbated as demand increases. Now, that doesn't mean renewable energies don't have environmental impacts also. Making of solar cells requires a lot of chemicals. Wind energy takes a certain amount of land, solar energy. So As they say in the energy business, there's no free lunch. But there are some lunches that are freer than other lunches. And so what you want to do is get the cheapest lunch you can find. Because the lunch is going to be the same, but why pay the most expensive price for it? Sir.
Biocides, საქართველოს ტექნიკური უნივერსიტეტი, ენერგეტიკის და ტელეკომუნიკაციის ფაკულტეტის დეკანი. Მაგნუთ, ძალიან კარგი ლექციისათვის. მაინტერესებს, გქონდათ თუ არა თქვენ შეხვედრა იმ მეცნიერებთან, ან როგორია თქვენი მოსაზრება ამ მეცნიერებზე, რომლებიც ამტკიცებენ, რომ კლიმატის ცვლილება დედამიწაზე მისი ბუნებრივი ციკლის განვითარების პროცესია. ანუ გარკვეული პერიოდის შემდგომ დედამიწაზე კვლავ დადგება გამყინვარების პერიოდი. და ადამიანის საქმიანობა მიმართულებით არ არის მნიშვნელოვანი და მეორე შეკითხვა თუ შეიძლება დეკანთან არის თუ არა დადგენილი არასაკმაყოფილოს მოქალაქეების ჩარიცხვა იმ პროგრამებზე, რა პროგრამებზე თქვენ ახორციელებთ საქართველოში. ანუ ერთიანი ეროვნული გამოცდის გარეშე როგორ შეიძლება მოხდეს თქვენთან სტუდენტი. მაგნუთ.
Okay, the question which I'm surprised it took so long to get to is some people claim that there isn't such a thing as global warming and climate change. But you know, science is a unique endeavor in a certain way. It's unlike many other human activities because it demands evidence. And it doesn't matter what one's nationality, religion, or political persuasion. A good scientist is trained and looks at the available data. And not just evidence from one person or one laboratory, but from hundreds or even thousands. And so, the people who claim that global warming isn't happening, they tend to look at 5 years or 10 years. In other words, they call what we call they cherry pick the data. They only take certain cherries from the tree because they have a preconceived hypothesis. This is not good science. And I'll tell you a personal story. When I started studying this some time ago, I was unconvinced because the data were still not strong enough. But I would argue in the past 15 years, the amount of data that has accumulated, when taken as a whole, not bits and pieces, when taken as a whole, and I've objectively views, the conclusion is inescapable. And I showed you that data. The long-term trends, even though there might be some cooling for a while, there might be a decade here, we're talking about hundreds of years, and we can compare that to hundreds of thousands of years before, where the change in the global average temperature is going up, and the rate that it's going up has never been seen in the fossil record before. So that's my response. You should look at the data skeptically. Every scientist should examine all the evidence, and as the evidence comes in, you put it all together, and the only consistent story that I've ever heard is the one I just presented, when you look at everything together. And I think the next question is for you.
Thank you very much for the question. So the only way for Georgians to enter the programs at STSU Georgia is through the Unified National Exam. There will be international students. In fact, the hallmark of a university is the opportunity to exchange ideas, and the larger pool, the more diverse the pool of students who participate, the better. So there will be international students, and they have a different path. They're not Georgian citizens. They're not eligible to take the Unified National Exam. So, but my colleague, Dr. Louven, is here, and when we finish with questions, if you have questions about the details of how that works, he can easily help you with those. So thank you very much for the question. I think the microphone's out. Maybe we could think, and I'd also like to try and reserve the last question after this, if we could, for a potential student, because you're the ones who are going to have to clean up this mess. And so we'd be very interested in asking one of the students who's in the audience to perhaps ask our closing question. But please.
Actually, I'm not a student.
Oh, great.
I'm a chef of development and electrical regimes of transmission company of Georgian TSO, GC. I have just one comment regarding big dams. I think the only way we may repair our independence and energy security is to build dams. Yeah, we agree that we have to somehow build by cost-benefit analysis, but it is only a way not to be dependent on import and on the oil prices, because if we don't increase the hydro usage of hydro energy, the consumption and dependence on imported energy will be increased. It was just a comment. And then a question. Thank you for very exciting lecture. It was very interesting. And the question is, what in the world is doing in order to improve some characteristics of renewable energies, because until now they are very unstable, and many of companies avoid installation of, for example, wind power plants due to their instability.
Do you ask about nuclear energy or renewable energy? Renewable. Okay. First, to your question that the only way you'll get security is to be energy independent. I'll be a little bit provocative and say that's the way you'll never get independence. Because no country in the modern world has all the types of fuel it needs to be totally independent. No country is an island. There's trade, there's people moving back and forth. Even if you produce energy like Norway, for instance, people use that as an example. Well, Norway produces a lot of hydropower and a lot of electricity, and it sells it. So it still needs oil, which it can produce in its area there. So there are a few isolated cases, but Georgia is not one of them. It doesn't have the resources, it doesn't have the infrastructure, and it doesn't have the geographical location that a country, and that's only one country of 4.5 million people. Every country in the world is dependent on trade, interaction, people moving back and forth. In the European Union, all the countries are dependent on each other. And I would argue it's a false goal. It makes a lot more sense to develop the resources that are appropriate for the country. Hydro here, bearing in mind that might change with climate change. Perhaps some solar, you have no oil and gas to speak of. And then to work out relations with as many countries as you can, because you're part of the globe. You're not an isolated island. You're part of the global community embedded in the region that you are. Now, I can be more specific. I know there's a lot of sensitivity about getting gas from Russia, and I certainly can understand that. But that's not the only source of gas. You can get gas from a lot of places. Soon you'll be able to get liquefied gas. The real key is to use less gas and substitute it. But to have a policy, if I were advising any government, and I've done this in our own government in certain forms, it's a false goal. It sounds great when you're a politician, but when you really think about it, it's not really attainable, except at perhaps exceptional cost. Let's take the United States. In theory, we could probably produce more oil. We produce a lot of coal, and we use all the gas we produce, but not oil. We still import about 30% of our oil. If we made a crash effort to get all the oil, the environmental damage we would do would be horrendous. Plus, we would accelerate climate change. So my point is, you can't take one out of context. It all comes together.
Let's take one question right here. That's.
Hello, I'm Timur Chichurov from Georgia. Yes, I'm a high school student right now. I'm planning to study in San Diego State University. Thank you. And after your answer to the question of one of our guests, I have views that you just refuse the potential of electric energy. You said that Georgia is not that wealthy because we don't have so much, how can I say, energy sources. I can say that electric energy is one of the most, how can I say, innovative thing right now because, for example, let's take Tesla Motors. They're making cars which are working on electric energy. And if we are going to say that it's way more expensive than the gas cars that work on oil, let's remember what was the price of the first car which were working on oil. And this, how can I say, the price of these devices which work on electric energy is decreasing, and the development of electric energy like solar plants, etc. are increasing, which makes me think that electric energy is one of the most important points on which we should be putting our hands on. So yes, and I have another question. Yes.
Well, this is great because I'm going to come back and teach here if there are more students like you. That's a terrific question. And the fact that you're in high school and asking that question is wonderful. And the question is, why not use electricity for everything, if I could imply what you're getting at. Many people have asked this question, including Tesla, the first Tesla, who lived not too far from where I worked at one point, and Edison and other people. Electric energy is a product, a commodity. It's not a natural resource. You don't take electricity out of the ground. You manufacture it, unlike coal, oil, or gas. So how you make the electricity is critical. If you use coal to make electricity, you're not going to gain anything. If you use oil or natural gas, as far as global climate change, if you use nuclear power, which we haven't discussed, you won't add to the greenhouse gas, but there's a whole set of issues. So, the full cycle of what you might want to think about, if you can make electricity from renewable energy, and then if you could find batteries to store the electricity when the renewable energy isn't available, and then you can make cars from the batteries, the cost of a Tesla wouldn't be $100,000. It might come down to something anyone could buy.
I thought,
yeah. But you're correct. That's the future. There are many people who talk about the electric world, but they've also talked about it since Edison in the 1890s. That's where superconductivity comes in, where you can transmit electricity, potentially, without any energy loss. And this is a vision, and that you have this vision is much more important that you have it than I have it. And maybe when you come to study, you'll go into one of the fields where you can actually make a contribution to that and develop new batteries, new technologies to store energy, new ways to make electricity that could be useful and even applicable right here in your own country. So thank you for the question.
You're welcome. And that was where I was going to ask you the question. As you know, we have a team in another university, I won't say the name, and we have a laboratory out there, and we're working in this laboratory for some researches, etc., etc. Will we have same possibilities in San Diego University? I mean, will we have laboratory for researches and some serious researches, not just simple high school quality researches? Yes.
Yes.
Cool, thanks.
So all students will complete a capstone design project, and the facilities that support that are just exactly as you described. And all along the way, it is our goal to involve students in research that is publishable, that will add to the cloud of global data. So, yes. I want to thank everyone for your kind attention, for so many terrific questions. If you will like us on Facebook, that'll be the best way to get information about upcoming lectures. We wish you a wonderful evening. Thank you again.